Hello students, now we'll discuss oxidation of aldehydes. That will be, you can say here, practical organic chemistry. Practical organic chemistry point. There are four types of tests were there to do the oxidation of aldehyde. Tollens, Fehlings test, Benedict test, Schiffs test. Now we'll see one by one. Now first, if you take Tollens reagent, so Tollens reagent generally what happen, a freshly prepared ammonical silver nitrate will take. Freshly prepared ammonical silver nitrate will take place. So now this ammonical silver nitrate test, when you treat with aldehyde, when aldehyde is warmed with a Tollens reagent, a bright silver mirror will be produced due to the formation of silver metal. Okay. Now the reaction is also called as a silver mirror test for aldehydes. Let us see here. See, aldehyde will be here. Now, ammonical silver nitrate is oxidizing into carboxylic acid. Salt will be forming. Then, along with silver, salt is forming. Because of this one, it looks like silver mirror. Let us see one by one how we can prepare the freshly ammonical silver nitrate. So, here what will happen? So, we'll take silver nitrate solution plus. So, we'll treat with a base. When you treat with the base, what will happen? We will be forming the Ag2O solid. This will be brown solid. Brown solid will be forming. Now, this brown solid, when you pass excess of ammonium hydroxide, right? Excess of ammonium hydroxide, so it will form the Az, Az, NH3 twice positive OH minus electron. So this is called as a freshly prepared, freshly prepared ammonical silver nitrate, ammonical silver nitrate. This one. Now, here what we'll do first, this will be given for aldehydes RCHO. This is for aldehydes will give. Now, aldehydes what happen now? We'll take the this freshly prepared ammonical silver nitrate AzNH3 twice plus 1. Silver will be plus 1 state. Now in the alkaline medium, it will be forming as, so RCOO negative plus NH3 will form. Then plus, you will be also framing the silver mirror solid precipitate. So right, it is a silver solid, then along with the this water will be there. So this case of when you're taking aldehyde, suppose when we take aromatic aldehyde, CHO, again, when you treat with a so ammonical silver nitrate positive plus OH minus will be giving the, so benzoic acid is forming, right? Again, same the byproduct will be like ammonium as well as silver, then water will be there. This one. Third one, it can also take alpha hydroxy ketones, alpha hydroxy ketones, alpha hydroxy ketones, alpha hydroxy ketones. Let us take alpha hydroxy ketone, alpha hydroxy ketone, how the structure looks like. So take here, this will be hydroxy and like this. This will be alpha position. Ketones, next carbon will be alpha carbon. So that is alpha hydroxy ketone. Got it? Yes. Now again, we'll take the same AgNO3, AgNH3 twice positive plus alkaline medium base will be giving the, see, oxidation nothing but loss of hydrogen. Oxidation nothing but loss of hydrogen. So here H2 molecule will be eliminated here. Right? So here one hydrogen is there and here one hydrogen. This hydrogen as well as this hydrogen both will eliminate. You will be framing the diketones will be forming. Diketones. It will be getting the diketones are forming. Yes. Then again we will be getting the silver solid precipitate. This third case is alpha hydroxyketone. Now we can also take formic acid. The fourth one, we also have formic acid. Formic acid. So here H, C double bond O, OH we have. Again, ammonical silver nitrate, we are taking positive OH minus. So here the reaction takes place with the formic acid is because of this ketone carbonyl carbon having the one hydrogen, right? So oxidation taking place now. So what happened now? It will be forming the carbonic acid is forming. Carbonic acid is forming. This is unstable. So finally, it will be converting into carbon dioxide plus and what? Like this. So formic acid also giving the silver mirror test. Another one we have, another one, fifth one, hemiacetal. Hemiacetal also gives the silver mirror test. Hemiacetal, how the structure looks like. R, C, H, O, R, O, H. So again, if you take here ammonical silver nitrate test, positive plus OH minus will be having the oxidation takes place. How the oxidation takes place? Just to look at here. So here, this sigma converting into here and this will be moving like this alcohol. So alcohol will form along with the R, C, double bond, O, H will takes place. See, we got again aldehyde. Again, will be oxidation will takes place here. So we'll get the R, C, double bond, O negative plus silver solid precipitate. So these are the five types of compounds that can give the Tollens reagent. Now we can see a brief slide. So we can see this particular slide. So clearly given what test, what kind of things will give, right? So Tollens test, what will take here? Tollens test will take silver mirror, ammonical silver nitrate will take here, no? Ammonical silver nitrate, that is AZ NH3 taken twice, positive plus one state silver. A freshly prepared ammonical silver nitrate, this one. We should prepare freshly. So otherwise it will be not that much of active, means not good. Positive test what happened? So you can see there is a kind of silver mirror is forming here. No, you can see here kind of white silver precipitate is forming. What and all test it will give? Aldehydes will give silver mirror, like ethanol, benzaldehyde will give, right? Acetaldehyde will give. Negative test. Ketones, no test for this one. Ketones will not give for this test. No reaction to the ketones. Acetone, right? So no test. Here short take is Tollens means silver lens. Right? Here lens kind of forming, that is a short trick to keep in mind. Next text, what happened? Next text will be Fehlings test. So Fehlings test, what actually happened here? So there are two types of solutions are there. Solution A, that is containing aqueous copper sulfate solution. Aqueous copper sulfate. Solution B, what we have to take here, alkaline solution of sodium potassium tartarate. Sodium potassium tartarate, that is Ruchelay salt. Ruchelay salt. When aldehyde is warmed with a failing solution, A deep blue color, a solution is changed to a red precipitate of cuprous oxide. You can see in the given equation, aldehyde we have taken copper 2 plus. This is blue in color. Alkaline solution will be forming as a acid. Then red precipitate is forming. That is cupric oxide. So cupric converting into cuprous oxide water. Now we'll see how this will be taking place. So here, if you see the if you see the sodium citrate will be like this. Sodium citrate. So here, so here, sodium citrate will be COO OH H OH H COO. So sodium potassium tartarate that will take that we are calling is a Rochley salt. So what nothing will happen in this case whenever you take aldehydes here, when you take aldehyde in presence of copper 2 positive, alkaline medium is converting into acid by forming the cuprous oxide that is red in precipitate. One will be you will be taking the aqueous copper sulfate. This will be CuSO4 here copper plus 2 state that is a blue in color. It is converting into copper plus 1 state. So copper itself get reduce oxidizing. Copper is undergoing reduction, whereas aldehyde group is oxidation, right? So again solution B will be having the sodium hydroxide will takes place, right? Then we will also take copper sulfate, sodium hydroxide. Then we'll take sodium potassium tartarate that we have given structure here, right? So we can also keep it as a notch, this one. That also calling as a Rochley salt, this one. Solution A, solution B will be there. So solution A, copper sulfate, solution B, so NaOH plus sodium potassium tartarate. So when aldehyde is formed with the failing solution, deep blue color will be converting into a red precipitate. Red precipitate is forming that is Cu2, copper plus 1 state is forming. Here Cu2 plus copper blue color converting into copper 2 plus 1. Now you can see here failing test solution. So solution A copper sulfate, solution B sodium hydroxide, sodium potassium tartarate. Right? The structure keep in mind. So here anyway it is not required to remember the structure. So just have an idea like this structure. So COO K positive, sodium potassium tartarate. It will give positive test for only all aliphatic aldehydes, not aromatic aldehydes. Aromatic aldehydes, no reaction for this one because this one is not that much of strong oxidizing agent as compared to Tollens. Aliphatic aldehyde will give the kind of no can see here brick red precipitate is forming. Brick red precipitate is forming in this case. Ethanol will give glucose also will give the in this condition because glucose having the aldehyde group is there. Which test will not give? Aromatic aldehydes will not give kind of benzaldehyde. Benzaldehyde will not give the test for this one. Ketones will not give the rest reaction. Right? So failings fails for benzene. That is a short trick to remember. Failings fails for benzene. Next we'll see the Benedict's test. Benedict test, what will happen in this case? Benedict test. So in the case of Benedict test, we will take the a solution is a mixture of copper sulfate solution plus sodium citrate solution. Copper sulfate as sodium citrate plus sodium hydroxide we will mix. In this case also same thing, copper 2 plus is reduced by aldehyde to give a red PPT will be forming of cuprous oxide. Same as the Tollens, but only one difference here. What will happen in that case? In that case, there we have taken sodium, potassium tartrate. Here what we are taking? Sodium citrate, copper sulfate plus NaOH. In this case, same thing what happened? Only aliphatic aldehydes. So CH3, C double bond O, CH. Now when you take copper 2 plus, it is in a blue color. When you treat with the base alkaline, it is forming as a CH3, C double bond O, O negative plus Cu2O, cuprous oxide. It is solid, right? A red PPT will be plus water will be produced. So this is what the identification or oxidation of aldehydes. You can see here, Benedict's test we can do for reducing sugars test. We can use for reducing sugar test, right? So here reagent will be copper sulfate solution, sodium citrate. In case of failing solution, sodium potassium tartrate. Here sodium citrate plus sodium carbonate we will take in this case. So here also, in this case also, we can keep here sodium carbonate will take this one, sodium carbonate along with this. Positive test will be kind of reducing sugar. Reducing sugars what happen? Free aldehyde group. Free aldehyde group in a sugar molecule or any hydrocarbons. Sorry, any carbohydrates. If free aldehyde is there, that will give the this test. Right? Can write here. Free aldehyde groups will give the test. Free aldehyde groups will give the test. What kind of PPT? A red PPT will be forming again same because of Cu2O, cuprous oxide solid. Will give the test for reducing sugar, glucose, fructose will give, right? Negative test again, no test for a benzaldehyde means aromatic aldehyde, no reaction. Non-reducing sugars, that means no free aldehyde groups. No free aldehyde groups will be no reaction. Non-reducing sugars, no reaction. Sucrose will also have the no reaction because there will be no free aldehyde group is present. How to remember this one? Benedict test, blood test. That means kind of a red brown, no? A red kind of PPT is coming, no? Reddish brown. Next, what we have? Schiffs reagent. Schiffs reagent. So you can see here, uh, this will be very kind of important. So need to be focused more here. Okay. Now, so dilute solution of aldehydes when added to a Schiffs reagent. The Schiffs reagent is this one. So P rose aniline, para rose aniline hydrochloride dissolved in water and its red color is decolorized by passing SO2 gas. SO2 actually is a bleaching action will take place in this case. SO2 decolorize the para rose aniline hydrochloride yields into a red color. This is known as Schiff's test for aldehydes. Ketones do not give the test for this. No test for ketones. Acetone, however, gives a positive test but slowly. So this point is important. Acetone will give only very slowly the reaction. Now you can see here, if aldehyde is absent in this solution, then colorless, look like a very white. If aldehyde is present, you can say positive test. You can say magenta, right? So here, this structure will be para rose aniline hydrochloride. This one. So here, para rose aniline hydrochloride. Hydrochloride. Simple in this case, what happen? Let us take RCHO. RCHO. In this case, what happen? In this case, para rose aniline rose aniline will be converting into acid will be forming like this, right? So here SO2 gas will be dissolved means decoloration takes place. So we can see here what is the short way to keep it in mind this particular case. Schiffs test, aldehydes conformation test. The reagent will be para, you can keep here para rose aniline hydrochloride plus SO2 sulfur dioxide will be taking. Sulfur dioxide will be taking this one. Sulfur dioxide. It is a colorless reagent. When aldehyde is present, it will show the pink color. When aldehyde is absent, no color. So if aldehyde is absent, no color. Aldehydes present, no, will give the thick pink magenta color. Aldehydes will give the test, ethanol will give the test, acetaldehyde will give the test, and it also give the benzaldehyde test. Aromatic aldehydes also this will give the test. Now, if you see the ketones, no, ketones is no test because it's not that much of strong oxidizing agent. Ketones, no color change will take place. As it is, white color will be there. Acetone, slowly, very slowly, but you can say ignore. Schiffs reagent, rose aniline hydrochloride, colorless reagent. Schiffs reagent give the fast color only with the aldehyde. Now we'll try to solve the few questions on this so that the concept will be much more clear for you. So first question is the reagent is used to distinguish between the acetaldehyde and benzaldehyde is. See, I told you acetaldehyde benzaldehyde can be CH3, CHO and PHCHO. That can be done only by Tollens reagent. Not Tollens reagent. So here Failing solution cannot give the aromatic aldehyde, but Tollens will give the both aromatic as well as aldehyde. It will give the HCH3CHO aromatic as well as aliphatic. They will give the test. Failing solution will not give aromatic, only aliphatic will give. Question. So option B is the right answer, not A. Now, question number 2. Which of the following compounds will give positive Tollens test but negative Failing test? Positive Tollens, negative Fehlings. That is aromatic aldehydes. So ethanol. So ethanol will be like acetaldehyde, CH3CHO. Aliphatic aldehyde. Both will give the Tollens as well as Fehlings will give. Formaldehyde. Again aldehyde is there, no? This will be given by both Tollens as well as Fehlings. Benzaldehyde. Benzaldehyde will be only for Tollens. Only for Tollens, not for failings. So they're asking that negative test for failings. That is option C is the right answer. Acetaldehyde will give the test for this one. Which of the following compounds will give positive Tollens test? Positive Tollens. So positive Tollens, which of the following will give the positive Tollens test? Which of the following will give the positive Tollens test? A will give aldehyde positive Tollens test. B will give beta-acetaldehyde. Aromatic aldehyde will give ketone. Will be not give the positive Tollens. So here answer will be A, B, C. 3 will give the positive Tollens test. So for Tollens test in the second question, what happened? A, B, C and D. In this case, so C will not come. Question number 4, what happened? The brick red precipitate is formed in the failing test is due to the formation of brick red test. Brick red formation is what? What's happening there? Copper 2 plus cupric oxide. Blue is converting into Cu2O solid. Cu2O solid. That is red, brick red. Right? That will be having the option B is the right answer. Match the following Schiffs test will give the pink color. So P2, Tollens test, silver mirror, Q1, failings will be brick red, that is 3 years. So this and this. Which statement is incorrect? They're asking, not correct. Aromatic aldehydes give the tolerance. Yes, perfectly all right. Ketones gives shift test. No. Yeah, we'll see this one. Slowly we'll give the ketones, right? Slowly we'll give the test. Aliphatic aldehyde gives a Fehlings test. Yes, this is correct. So copper 2 plus is reduced to copper plus 1 in Benedict test. Yes, this is also correct. So Benedict test what happened? Copper 2 plus is converting into copper plus 1. But ketones will not give the test in this case. But slowly, but you can ignore the this one. Aromatic aldehyde give the tolerance test. Aliphatic aldehydes give the Fehlings test. Copper 2 plus reduced to copper plus 1 Benedict test. So B will be the incorrect statement. Seventh question, what will happen? So how many of the following compounds give the positive shift test? So here acetaldehyde, formaldehyde, benzaldehyde, as well as ketone. Schiffs test they're asking. That means what happened? Schiffs test will give only for aldehydes as well as benzaldehyde also will give. So three will give. Ketones will not give the test for this one. Ketones will not give the test for this one. Question number 8. What happened? Which reagent is freshly prepared and should not be stored? That is ammonical silver nitrate test. That is C is the right answer. Assertion. Schiffs reagent gives immediate pink color with the ethanol. Correct only, right? Aldehyde is present, will you? Aldehydes restore the color of decolorized rose and linen dye, whereas ketones do not react. So assertion is right, reason also correctly explaining. That is option A is the right answer. Okay, guys. Now we'll see the overall four tests are given. Schiffs test, Dolenz test, Fehlings test, as well as Benedict test. You can see here it will be having the pink color, active, visual appearance pink color, right? Tollens, silver, positive converting into silver metal. In both cases, plus 2 converting into plus 2, plus 1. Brick red precipitate. Here, silver mirror glass is forming lens now. So visual signal, pink color, silver mirror and glass, black, red precipitate will be forming. Ketones, no, this will be, H will be there, not ketones. Okay, this alone modify. Aromatic aldehyde, so will not give this test. So in this case, so here generally they will not react. So here this will be Tollens test. This will be aromatic aldehyde. So aromatic aldehyde will give the positive test, not this one, not this compound, and they will not react in this case. It's not aromatic compound. So PHCHO is the aromatic compound. Ketones, no reaction, no reaction, no reaction. No test will be give the ketones. So finally, thank you guys. So do follow for more content. Okay, this I'll upload this PDF in my description. So please take it down. Thank you guys.